Okay, so we're going to talk about linear inequalities. I think they're all linear. So this is an inequality. You've probably seen one before. This is y is less than x minus 2. So if you look at the line, in fact, I think I can change this. Okay, so there's the line y equals x minus 2, right? So if I graph the less than, you notice that the line does a couple things. So when it went to less than or equal to, it shades down. That's interesting. When I go to less than, it makes that a dotted line. So this is a way that we can represent the solutions are anything in the shaded area, in this case, the blue area, right? You can see I can move this point around, and anywhere I move it where it's in the blue area, it says true for everything. Because if you plug in those values like 4 and -3, for example, if y is -3, you can see that's plugged in right there, and x was 4, 4 minus 2 is 2, is -3 smaller than 2? That statement is true, right? So any point where, and it's not just the integer points, but this particular program goes just to integer point. There's actually an unlimited number of points. There's millions and millions and millions, infinite number of points in that shaded area. So we can't say, well, there's just one solution or something. There's tons of solutions. Anytime it says true, it's a solution. Now you notice on this side of the graph, if you plug in those values like 1 and 4, so if y is 4 and x is 1, 1 minus 2 is -1. 4 is not smaller than -1. That's false. So that definitely is not part of the solution. I hope you know the answer to this, but what would happen if you if you had a point right on the dotted line? So let's look at that. So it means x is 5, y is 3. So if y is 3, 5 minus 2 is 3. Is 3 smaller than 3? No, that's not true. So that false, it means that any point on there is actually a false, so it's not really part of the solution there, folks. But if it is on the line, yeah, so, but as soon as it gets in there, it's true. So anything in the shaded area is part of the solution there. Okay, so let's go to the lesson. Just want you to get the concept there. So that boundary line is that dotted line. It goes right up to the line, but doesn't include it. It's basically 3 steps. First, you want to solve it for y. Kind of put it in slope intercept form because it's pretty easy for us to graph it from that form. Graph, you decide, is it going to be dotted or solid? So does it have an equal sign as part of the inequality? Is it greater than or equal to, less than or equal to? That would be solid line. If it's just less than or just greater than, it would be dotted. In shade, you may want to test a point. And what it's talking about testing a point is kind of like we were doing here, right? If you plug in a point like 6, -1, a lot of times we'll plug in this point, 0, 0. Because it's easy to plug in. 0 is less than 0 minus 2. 0 is less than -2. That's not true. So that 0, 0 point is not going to be in the solution region. So that's just one way of kind of checking to see which way to shade. So the shading should not go towards 0, 0 in that case. Okay, let's just try this one. So we're going to try to put this in the right form, or at least a form that is easier for us to graph, and then we'll graph it and see what happens here. So I'm going to subtract 2x, and you get -5y is less than -2x minus 10. Remember, if you divide by negative, like we are here, you get y is, instead of less than, it's going to be greater than. The sign is going to switch when you divide by negative. So it'd be 2/5 x minus 2. Okay, that's not too hard a thing to graph. So, but notice the sign is greater than, so no equals. So it's going to be a dotted line. So I try to remember that. Sometimes it's hard to remember. Up 2 over 1, 2, 3, 4, 5. We're down to 1, 2, 3, 4, 5. So I'm going to make a dotted line that kind of goes through those points the best I can. So it's got 3 nice points on there. Now we have to decide which way to shade. So this is the greater than sign, right? So greater than. So some students just kind of know where to shade. They're like, oh, well, I'm pretty sure greater than means kind of bigger than. So I think the solutions are going to be bigger than that line. So you shade kind of above that line. And that looks right. But let's just double check. So if you weren't not sure, you can always test a point, because sometimes we come across some pretty weird shapes. So let's test a point like 0, 0, right? So if I take the point 0, 0 and plug it in, And that would be 0 is greater than 2/5 times 0 minus 2. Well, 2/5 times 0 is just 0 greater than -2. That's actually true. Right, because it's true, the green should be in the shaded region. It is. We did shade in the correct direction. That's excellent. Okay, try this one. Again, start with the line x equals 2. And we're going to graph that with a solid line because um, it's equal to, so it's a solid line there. And now it's just a matter of which way to shade. Well, if you learned a little trick about what is greater than shade up, it doesn't help you in this problem because straight up is, what is that? I mean, it's a vertical function. So the question is, do I shade to the right or to the left? If you're not sure, like I think I'm going to shade bigger than, so I think I'm going to shade to the right, but I'm just going to plug in a point to see. 0, 0 is a pretty easy point to plug in. So if you plug in 0, 0, let's see what happens. I'm hoping it's false. I'm hoping it's not in the solution region. So 0 is greater than or equal to -2. Is that true? Oh, it is true. By the way, it really helps when you graph your line. This is funny. At -2, I believe it said -2 to start with, so that the shading. See, this will help you correct your mistakes. So if you make a mistake, that's beautiful. Oh, I don't see any mistakes here. So if you have your shading to the right there, you go, oh, yeah, that should be part of the solution. That's why I was kind of stumped there. Wait a second. Like, did I make a mistake? I did make a mistake. So this is definitely true, right? Because 0 is bigger than -2. So 0 should be in the shaded region, and it is. We shaded to the right. I just didn't shade quite enough. It would keep going there to the right. That's the idea of this. Let's try this one. Again, start almost with the line y equals +3. But I'm not going to draw it because there's no equal sign. I'm just going to draw a dotted horizontal line where y is equal to 3. But I really want this to be greater than, so I think I'm going to shade up. I think it's going to look something like that. But to be sure, it's not a bad idea to substitute a point. Let's just plug 0, 0 in. That would be 0 bigger than 3. Is that true? 0 is not bigger than 3. I think that's false. Therefore, the shading should go out, not towards 0, 0, should go up towards the rest. Is either above or below. In this case, the shading is definitely above. Okay, so let's try to solve this equation. You want to solve it for y typically, so I'm going to subtract 2x. Get -4y less than or equal to -2x plus 8. Divide by -4. Get y is greater than or equal to, because I divided by -1/2 times x minus 2. So that looks like a y-intercept of -2. Slope is up 1/2 in the positive direction, up 1/2, up 1/2, and so forth. And this is going to be greater than or equal to, so it will be a solid line. I missed a point there, but something like that will be solid. And then you're going to be greater than, so I think you're going to shade up above. Not a bad idea to check a point, so if you do, bother to check a point. So let's just 0, 0. 0 is greater than or equal to 1/2 times 0 minus 2. So 0 is bigger than or equal to -2. Is that true? That's true. That should be in the shaded region. It is. Therefore, we're good on that one. That's the lesson. Wow, that was really fast.